Okay, I'm not going to tell you. So that's your homework. No, just him. It's easy. Okay, so I like you to find out what's the abbreviation of IEEE. I think everyone have heard of it, right? International what? IEEE. No. So next time you're going to tell us what it is. Okay? Okay. Let's start the second chapter. So everyone has a copy of the second chapter, right? Say again, so that everyone can hear you. IEEE stands for Institute of Electrical and Electronic Engineering. Okay, it's a international organization that control or provide standards and information for electrical and electronic technology. Okay. So in the second chapter, we are going to have an overview of digital logic, right? This is not new here. There are two main types. The first one is digital and second one is analog. We all know that the difference is the first one has a discrete behavior, right? Non-continuous. In binary mode, we have the logic of 0 and 1. In decimal, we have the logic, the states are 0, 1, 2, 3, up to 9, right? 10 differences. Okay, so these are examples. Analog is different. It has continuity in a range from a minimum to a maximum in the range, right? There are uncountable possibilities there. About variables and functions, we have learned from last semester in discrete math that variables are what? What is a variable? Explain that in English. It's a symbol to represent something, right? In a function. For example, usually we use a single alphabet to represent a variable. Functions would be functions of variables, right? Could have one variable or more than one. These are examples. The first one, function Lx equal to x, having just one variable. The next one has two variables. It's a function using AND logic, right? x1 and x2. The next function use OR logic. Okay. The next one use combination of AND and OR. Also, we can use NOT logic, right? A complement, a combinations of AND or NOT to create a more complicated function, right? Let's see a picture of a switch here. Uh-oh. This is a binary switch, means that it has two possible states, closed or open, and we use a variable to specify the state of a switch. Okay, 1 means closed and 0 means open. So it depends on the assumption. It could be vice versa. You can sometimes a textbook, a book would use different logic. 1 means open and 0 means closed. So it depends. You have to check on that. Okay. So X is used to specify the status of the switch. Okay, open or closed. In this textbook, they use 1 to represent switch is closed, right? And that's a symbol of a switch. Okay. Okay, next picture. It is a simple circuit. Having a switch here, and there is a battery here. What would happen to the light if X is equal to 1? 1 means closed. The light would be on or off? On, right? If X is equal to 0, then the light would be off because the circuit is open, right? And this circuit could be drawn this way using a different ground. Each one has a ground there. Ground here at the light and the power supply. Okay, that's easy, right? What about the next one? This circuit. What happens if x1 and x2 are 0? Both of them are zeros. What happened to the light? 0 means open, right? So the light would be off